Okay, so carrying on, if we look back at this form of f dash of naught, and bearing in mind what we've just said about cosh and sinh sigma d when omega is large, cosh sigma d looks like e to the sigma d over 2, which is large, because the real part of sigma involves a root omega, which is large. So in comparison to 1, this term is very large, so we can ignore the 1. So f dash of naught is approximately I a sigma divided by omega times sinh sigma d, but sinh sigma d we can replace with e to the sigma d divided by 2, multiplied by, in the square bracket, ignore the 1, and then cosh is e to the sigma d divided by 2. And then these e to the sigma d's cancel, and so do the 2's. So this is equal to minus I a sigma over omega. Okay, so let's carry on. So what we've got then is that for omega large, f dash of naught is approximately minus I a sigma over omega, but we just worked out what sigma was here. That's sigma, so we can substitute that in. So what we get here then is minus IA over omega times sigma, which is root omega over 2 times 1 plus I. So if we tidy that up a little bit, then that's equal to A over root 2 omega into, so let's put this minus I into the bracket. So minus I times I is 1, so I'm left with 1 minus I in the bracket. And probably it's convenient then to rewrite that as A over square root of omega times 1 over root 2, 1 minus I, because then we might notice that that bit there, 1 over root 2 times 1 minus I, is e to the minus I pi over 4. So therefore, putting this all together, going back to the beginning and reminding ourselves what the definition of u was. There's the definition of u. So du by dy at y equals naught. That's the real part of e to the I omega t times f dash of naught. And if the frequency is large, omega is very much bigger than 1, then du by dy at y equals naught is then approximately the real part of e to the I omega t times f dash of naught, which we've just worked out its approximate form. It's a over root omega times e to the minus I pi over 4. Well, a is real, omega is real. So du by dy at y equals naught is then approximately a over root omega times the real part of e to the I omega t times e to the minus I pi over 4, which is then a over root omega times cosine of omega t minus pi over 4, which is the form we were asked to get it in, and we were asked to identify phi, which is this phase difference here. So the phase difference phi is equal to pi over 4.